Hello and welcome. If you're currently tackling your airline transport pilot license theory, yeah, that huge intellectual climb, the ATPLs, you definitely know the sheer volume of information can feel, well, pretty overwhelming.
It really can.
But that's why we're here. We're going to provide that shortcut, sort of extract the crucial knowledge nuggets you absolutely need to master those exams.
Exactly. In our deep dive today, it's focused squarely on instrumentation. Now, this isn't just about, reading a gauge.
No.
It's about understanding the fundamental characteristics, the definitions, the engineering compromises involved that turn these invisible physical phenomena into usable data for the pilot. Our mission really is to distill that core material, the stuff that's guaranteed to show up in your ATPL theory questions.
That's absolutely right. And it doesn't matter if you eventually step into a cockpit full of, traditional analog steam gauges or a really cutting-edge glass cockpit.
Yeah.
The foundational design principles, they just remain the same. You really have to understand why an instrument is shaped the way it is, what its limits are, range, accuracy, and why those color codes are so universal and frankly, mandatory.
And we are setting the tone for, let's say, extreme precision right from the start here. Before we even analyze how a needle moves, we have got to lock in those crucial unit conversions and standardized values.
Absolutely essential.
These numbers, they define the standard atmosphere, the standard operating environment, and knowing them cold, well, that's the non-negotiable first step towards accurately answering those instrument questions.
Okay, let's unpack this. Let's kick off with standard units and conversion factors. These are, like you said, foundational, often the easiest points to grab on the exam, as long as you've really internalized them.
Yeah, gotta know them.
Let's begin with distance, because, well, we use a pretty unique system in aviation, don't we?
We certainly do. We deal with meters, kilometers, and feet, sure, but for navigation and performance, the nautical mile, that's king. And it's critical not just to memorize the number, but maybe understand a little bit where it comes from. Historically, 1 nautical mile, it represents approximately 1 minute of latitude on the Earth's surface.
Ah, okay. That context kind of explains why it's a slightly, let's say, messy number, not neat and round.
Exactly. So the specific values you need for the nautical mile, or NM.
Yeah, let's nail those down.
A nautical mile is precisely 60-80 feet.
60-80 feet. Got it.
And if you're working in metric, which is common internationally, that converts to 1,852 meters.
1,852 meters.
These two numbers, 60-80 and 1852, they are absolute repetition points for your study. They form the basis of so many navigational calculations. You'll see them again and again.
Okay, 60-80 feet, 1,852 meters. And just to be clear, we also sometimes deal with statute miles, right? Like road miles. You might see those occasionally.
You might, yeah. A statute mile, often written in MEOM, it's a bit shorter. It's 500 and 280 feet, or 1,609 meters.
600 and 280 feet. Okay.
But again, really focus your memorization efforts fiercely on the nautical mile. That's the standard unit for speed, which is knots, of course, and distance in air navigation.
Excellent advice. Focus on the nautical mile. Okay, once we've locked in those constants of space, let's move to the constants of the environment. The atmosphere itself. Instruments like the altimeter, they're essentially just highly specialized barometers.
That's fundamentally what they are, yes. So understanding the definitions of standard pressure is absolutely mandatory.
Now, here's something that always puzzled me a bit. Why do we need 5 different ways to define one standard atmosphere, or 1 atmos? Doesn't that just add to the memorization load? Seems complicated.
That's a really great question, and honestly, it reflects the historical and regional complexity of aviation. We need those 5 definitions because different regions, particularly the U.S., they still rely heavily on older imperial units.
Right, inches of mercury and so on.
Exactly. While the rest of the world, and importantly international standards organizations, they lean heavily on the metric system, specifically hectopascals. So you just have to be prepared to accept, report, and crucially convert between all 5, especially when dealing with critical pressure settings like Q and H for your altimeter.
Okay, that makes sense. You need to speak everyone's language.
All right. Many thanks for listening to this free part of the ATPL Theory podcast. If you want to continue learning and access the full comprehensive guide, go to my Patreon at patreon.com/ATPLtheory or my Hero at herohero.co/ATPL. That is patreon.com/ATPLtheory or herohero.co/ATPL. Wishing you all the best